got to work with. Converting fractions, decimals, and percents.
That one's really important. Our students better do awesome on that one, and we better not get this wrong, otherwise the bomb's going to explode. So, a lot of times I just refer to this as FDP. I don't know if you guys do the same. And we talk about how we go from fraction to decimal to percent, and then vice versa. What do you do to help your students remember changing?
Well, one of the big things that we talk about, especially with decimals and percents, is we use Dr. Pepper.
Oh, yeah.
If you want to go from a decimal to a percent, for example, if we had 0.93 and we want to change that into a percent, I need to move that decimal point 2 places to the right.
Yeah, that's a really important idea. When my students are going from fraction to decimal, for example, we'll do 9/10. When my students are going from fraction to decimal, I tell them horse and cowboy. That means that the number on top is my cowboy, so the 9 goes on the inside when I divide, and the 10 stays outside. So making it into a decimal ends up being pretty easy because we just add the decimal, bump it up, and 10 goes into 90 9 times. So the 9/10 is equal to 0.9, which we read as 9/10. So if we want to change a decimal to a fraction, we can read it, say it, write it.
Really important to understand those place values.
And the other real easy hint that I've taught my students with changing decimals to fractions, if I have 0.31, 31 hundredths, I can put a 1 underneath that decimal. Then I just need to add 2 more zeros, and that would equal 31 over 100. Now obviously I need to make sure I reduce. If I don't reduce, I'm going to get the answer wrong. You can't reduce this problem, so we're done there. So let's take a look at what the bomb challenged us to do this time. The bomb challenged us to convert 17/20 to a percent. Okay, so we need to change 17/20 to a percent. It also challenged us to change 40% to a decimal, then fraction. So we need to change a fraction to a percent and a percent to a fraction.
Alright, so I think what I would do first on this one is I would use your horse and cowboy method to change that fraction into a decimal. So I'm going to take the cowboy who's on top and put him inside the house. The horse stays outside. I know that 20 doesn't go into 17, so I'm going to add a decimal point and a 0 there. My decimal point's going to go straight up. 20 goes into 17 0 times. 20 goes into 170 8 times. 8 times 20 is 160. I subtract, I get 10. There's another 0 there that I can bring down. And 20 goes into 100 5 times exactly.
So you think the answer is 85%. Well, I actually might have done this a different way because I know I talk to my students about proportionality and relationships. So, if you wouldn't mind erasing your work. Okay. So I take a look here and I have 17 over 20. I know that percents are always out of 100. So I have that 100. There's a relationship there. I know that 20 times 5 is 100. So all I need to do is do 17 times 5, and that also gets 85. So I think we're pretty sure on that answer being 85%.
I like it.
All right, so our next one is 40%. 40% to a decimal and then to a fraction.
Alright, I was talking earlier about how Dr. Pepper can be used to change a decimal to a percent. It can also be used to change a percent to a decimal. So if I have 40%, the first thing I need to think about is where's the decimal point in the number 40%?
Out of sight, it's to the right.
Out of sight, to the right. So my decimal point is right there. if I'm going from a percent to a decimal, I need to go 2 places to the left. So I'm going to move my decimal point 2 places to the left, and I get 0.4. That would be the decimal, or 4/10.
Now, you just read it how it's said correctly. You didn't say 0.4, you said 4/10. So I know that I'm going to write it as a fraction as 4/10. Okay? 4/10, 4/10.
If we put this in the bomb, you think it'll blow up?
I'm afraid it might, because these are both even numbers.
That's true. That means they can both be divided by 2.
Alright, so we better reduce this, divide by 2, and we have 2/5. Can I do any more reducing?
I don't think so. I think 2 and 5 don't have any common factors, so that's our answer.
They're both prime numbers. That's kind of this is actually the only even prime number. It's kind of a cool one.
You're right.
So, we got our answers of 2/5 and 85%. Let's throw that in the bomb, and hopefully we live to see tomorrow.
Alright, I hope this works.
Alright, let's check it out. Alright.
Alright, we got it correct.